Today, you're gonna feel like you're in an algebra class rather than a geometry class, because we're gonna spend today looking at radicals. We're gonna look how to simplify them, how to multiply them. I'm gonna show you how to add and subtract them, even though that's not the more important part. And then we're also gonna divide them. Some of you have already demonstrated in different lessons that you know how to do this, so it might be review for many of you. But just given my experience, I think most of you, might be new, and so let's get started. When you're working with radicals, a radical is basically something that has a radical sign around it. We're specifically going to be working with square roots, but a radical could also be a cube root or a fourth root or any root, right? But again, we're just working with square roots. It's important that you know what your perfect squares are. These are the numbers that when we take the square root of them, they turn into nice even whole numbers. So if I were to take the square root of 4, I would get 2. The square root of 9 is 3. The square root of 16 is 4, and so on. And so this list right here are what I will refer to as the magic numbers. So when we are simplifying radicals, you're trying to find a number on this list that will divide evenly into the number we're working with, okay? How do you simplify a radical? We want to find two numbers that will multiply to get the given value. So whatever number's under that radical sign, we want two numbers that multiply to be that value. One of the two numbers must be a perfect square. If you can't find one, then it may already be simplified. Okay. Once you find those two numbers, you simplify the perfect square, meaning you take the square root of it, and that number is going to come outside the radical. You're going to leave the other factor inside the radical. Now, if you did this, and the number under the radical still can be simplified, you need to do it again. Now, I will share with you a way to look at your perfect square list so that you only have to simplify once. So our first example, we've got the square root of 18. So this is my recommendation. So here's my list. Find where the 18 falls. And 18 falls right between 16 and 25. And then work your way up the list this way, meaning think to yourself, does 16 go into 18 evenly? No. Does 9 go into 18 evenly? Yes. So that would be the largest perfect square. It's going to be 9 times something. In this case, it's 9 times 2. So the number that's the perfect square, you'll see me circle it. I'm going to take the square root of 9, and the square root of 9 is 3. So that comes outside the radical, but the 2 must remain inside. So that's how the square root of 18 would simplify, would be 3 times the square root of 2. All right, let's do the square root of 32. So I look at my list, 32 falls in here between 25 and 36. So I start with the 25. 25 does not go into 32 evenly. 16 does, all right? I can break that down into 16 times 2. Now, I just want to point out that 4 also goes into 32. So if you start at the low number, there's a good chance you will have to continue to simplify, or your final answer won't be completely simplified. So always start with the larger. All right, so I'm going to circle the 16, and the square root of 16 is 4. So that comes out, but the 2 stays in. Square root of 80. Well, 80 falls between 64 and 80, so I work my way up until I get to a number that divides evenly into it. And let's see, 16 does. This is where you're going to have the calculator's going to come in handy, right? Square root of 80 can be 16 times 5. So again, I circle the 16. The square root of 16, which is 4, comes out, and the 5 stays in. Now you'll notice examples D and E already have a number out in front, and that's okay. So this is just 2 times the square root of 24. So it's still going to be 2 times, and then I'm going to break down the 24 in here. All right, 24 falls between 16 and 25, and as I work my way up, 4 is the only perfect square, so this will break down into 4 times 6. All right, 4 is the perfect square. So notice, all right, there's already 2 out there. So when I take the square root of 4, another 2 comes out, and the 6 will stay in. All right, so I just need to remember the 2 that I brought out is just going to get multiplied to the 2 that's already there. So the final answer will be 4 times the square root of 6. So again, 3 times the square root of 48. There are many perfect squares that go into 48, so we want the largest. So find where it falls and work your way up. And 16 goes into 48. So we'll break this down into 16 times, and it's 3. So when I take the square root of 16, the 3 is already out there. I'll bring a 4 outside with it, leave the other 3 inside, and then finish it by multiplying. So final answer will be 12 on the outside with the square root of 3. All right, that is how you will simplify a radical. Now, to add or subtract. We won't be doing too much of this, but I didn't want to skip it. To add and subtract radicals, they must have the exact same radical part to add or subtract them. Just like with variables, you can't add an x to a y, you can only add an x to an x. So you can't add a square root of 5 to a square root of 3. All right. We can, though, add a square root of 5 to another square root of 5 part. And we're going to treat it just like we do variables. We're only going to add the coefficients or the numbers in front. So the square root of 5 would have a coefficient of 1. Here we've got 4 times the square root of 5. So I'm going to add the 1 and 4 together for a total of 5, and then I just stick the radical part behind. So notice in G, when you look at this, you might say, oh, that's not going to work. All right. Well, the second bullet says we always have to simplify our radicals first, then see if we can add or subtract anything. All right. So the square root of 48, we're going to simplify that. So I go to my list, slide this back up, and work my way up. We know 16 goes into 48 3 times. So I would circle that, bring a 4 out, leave the 3 in. So that simplifies to 4 times the square root of 3. All right, come back up here, minus. Got a 3 in the front. I'm going to break down 12. Well, the only 2 choices I have for 12 is either 9, which does not go in, or 4. So I'll break this down into 4 times. I can do 3. Sorry, let me slide this back up. So when I take the square root of 4 and I bring this out in front, all right, I'm going to have 3 times a 2 with the square root of 3 behind it. So we've got 4 square roots of 3 minus, and then this is really 6 square roots of 3. Now I have the same radical part. So I'm going to add 4, and the minus 6 gives me negative 2 times the square root of 3. All right, H. None of these radicals are the same, so we're going to simplify first. Square root of 8 breaks down into 4 times 2. Take the square root of 4 out, so that will be a 2, with a 2 staying in. 18, we did that above. We know it breaks down into 9 times 2. All right, square root of 9, which is 3, comes to the front, and the 2 stays under. And then minus the square root of 3, that does not break down. It is already simplified, so I just carry it down. Now that they're all simplified, remember, you can only add ones that have the same radical part. So the only things I can combine is the 2 root 2 with the 3 root 2. So that's a total of 5 square roots of 2, and then I just put the minus square root of 3 behind it. This would be our final answer. Okay. Again, we won't be doing too much with adding and subtracting. That's not really a skill that we need for our next unit. But I didn't want to leave it out, and it would be good practice still simplifying. Now, multiplying radicals is a skill that we need. You can only multiply numbers times numbers, or a radical times a radical. Okay. To multiply radical parts, we just multiply the values that are under the radical sign, and you keep the square root around the product. You do need to still simplify, but you have the choice. We can either simplify them first, then multiply, or we can multiply them, then simplify. Okay, it's up to you. I personally just like to go ahead and multiply, then simplify at the end. If I notice the numbers I'm putting together are going to be super large, then I might simplify first ahead of time. But that's typically not going to be our case for what we're going to be doing. So for letter I, I've got the square root of 3 times the square root of 6. Since they're both radicals, I'm going to multiply the numbers underneath, and that becomes the square root of 18. There is a perfect square that goes into that. It's a 9. 9 times 2. And then when I take the square root of 9, a 3 will come to the front, and the 2 will remain underneath. Squaring and square rooting are actually opposites of each other. So the quickest, simplest way to do this is just to say that the square and the square root cancel, and you're left with the number that's inside. All right, fast and easy. Or remember that squaring means that you take what's being squared and multiply it by itself 2 times. So you could also just write it as the square root of 5 times another square root of 5, which will give you the square root of 25, which is a perfect square. So you get the same. All right, so in case you just don't recognize that, then write it out and multiply it that way. All right, letter K, we've got 6 times the square root of 8. Well, the 6 is a number, and the square root of 8 is a radical. So I can't actually multiply those together. I can stick them together, meaning get rid of the dot. But I do notice that the square root of 8 can be simplified. I can break that down into 4 times 2. So when I take the square root of 4, a 2 will come out. So final answer will be 12 out in the front of a square root of 2. All right, and then letter L. We've got numbers in the front and radicals. So numbers times numbers, that gives me 8. Radical times radical, 3 times 12 is 36. The square root of 36 is a perfect square. It actually just becomes 6. So final answer, 8 times 6 is 48. Okay. So we've simplified, add, subtracted, multiplied. The last thing to do is to divide. All right, when we divide, the important thing is to remember is that you cannot leave a radical in the denominator of a fraction. So if you're doing the math and we get a radical sign in the numerator, that's okay. If it's in the denominator, then we need to keep going. What we're going to do is we're going to rationalize the denominator, meaning we're going to multiply the numerator and denominator by the same radical. All right, because when you do the same thing over the same thing, like A over A, that just equals 1. And we can multiply anything with 1 by 1 without changing it. So when I look at letter M, I've got the square root of 3 over the square root of 5. All right, they are separate radicals the way this is written. I will point out, well, I'll talk about that in the next one. So we've got the square root of 3 over the square root of 5. So in order to rationalize this, because I can't leave that square root of 5 there, what I want to do is I'm going to multiply the top and the bottom by another radical. It's got to be the same. But the object is to turn the bottom into a perfect square. So the easiest way is just to simply multiply it by the same radical that's there. So if I multiply the square root of 5 times the square root of 5, I will get the square root of 25 on the bottom. And the square root of 25 is a perfect square and just becomes 5. All right, so that takes care, and I've now rationalized. But now I got to go back and do the math on the top. So the square root of 3 times the square root of 5 is the square root of 15. If I look at my perfect square list, there is not a perfect square that divides evenly into that, so it just remains the square root of 15. That is your final answer. It's been rationalized. Now notice letter N. There's one fraction under one big radical sign. This is exactly the same as the square root of 6 over the square root of 7. All right, I can break it apart like that. It has the same meaning. So now I can just focus on the bottom. Again, the simplest is just to multiply top and bottom by the same number, make it whatever's in the denominator. So I will end up with the square root of 49, which is just 7. Now I have to go back and do the math in the numerator. So the square root of 6 times the square root of 7 is the square root of 42. And if I look at my list, all right, you want something to go in to 42, but it actually does not. Right? I could do 2 times 21, but neither of those are perfect squares. And we have to have a perfect square in order to simplify. All right, letter O. Now, something that you can think about. All right, we've got the square root of 12 over the square root of 8. All right, again, I'm going to put this under one big one. I'm going to reverse what I did above. Because one thing I notice is that 12 over 8 does simplify a little bit. So if I do that, divide both by 4, I end up with 3 over 2. Sometimes that helps rationalize it just by simply doing that. But in this case, it didn't, right? So I'll go back, I'll split them apart again. But I do have smaller numbers that I'm working with. Sometimes that makes it a little easier. All right, so instead of doing the top and bottom by the square root of 8 all the way back at the beginning, which I could have done, all right, I'm now multiplying top and bottom by a smaller square root of 2. All right, I always do the bottom first because this will give me the square root of 4, which is just 2. And then square root of 3 times the square root of 2 gives me the square root of 6, and that does not simplify. All right, so just look at your numbers and see if you can simplify first. This might make it a little easier. Now, I know some of you, when you write this fraction here, are going to be able to go from this step to this step, meaning you don't need to show me the square root of 4. That you know what's going to happen here is that's just going to turn into 2. All right, and I'm okay, but these are our notes, so I'm just showing why we're going from 2 of the root 2's to just a single 2. All right, look at letter P. A couple more examples, and we'll be done. All right, so if I look 5 over 98, that does not simplify. But 98 is a pretty big number. All right, so I'm going to look at my perfect square list, see if I recognize a number that 98 might go into. Because I certainly don't want to do the top and bottom by a square root of 98. 98 times 5 is going to be really, really big. All right, so first thing I'm going to do, I'm just going to write it separate. Not that you have to, but I like to. So I'm going to think smaller. What I notice is that 98 goes into 196. And 196 is a perfect square. Well, to get to 196, I need to multiply 98 by 2. So you don't always have to choose a radical that's exactly the same. All right, so if I multiply top and bottom by the square root of 2, I will get the square root of 196 in my denominator, which is the perfect square, and will become 14. As long as these are the same, you're fine doing that. So now when I go back up, I'm just multiplying square root of 5 times square root of 2, which is square root of 10, and that does not simplify. So that would be my final answer. All right, again, you could do 98 over the square root of 98, but you're going to be working with some big numbers. All right. The last one, we've got Q. We have 3 times the square root of 18 over the square root of 6. Again, look at the fact that 6 goes into 18, right? So if I have 3 on the outside, but I've got this 18 over 6 and put it together under 1, this really is going to be 3 and then the square root of 3. And I'm done. All right, so look for that simplifying. That's going to help make things go a little faster. All right, so today, all about radicals. Keep the notes handy and our examples to help you with the problems.